of Venn diagram exists, and there's just so much more data, so many more systems and pieces of information that we got to integrate, and then so many more people using the data nowadays that it feels like a challenge. I don't know if anybody has kind of experienced that, but the technical skill level of the stakeholders that I end up working with kind of varies a lot. And the quality of the data that I work with varies a lot, and the number of technologies that I end up working with is just kind of all over the board. Um, I don't know if anyone wants to just be like, yeah, me too, or raise your hand in the video to agree or not
Everyone
agree.
has their own
Yeah,
special use case.
right. Um, and so one of the things that I kind of found was that, you know, everybody's kind of building these silos of use cases, and there's a lot of commonalities between what's being built. And I think Amazon, Google, Microsoft, they're kind of like catching on to this because they're seeing this at a higher level than what most companies see inside or internal to their organizations. They almost get like a cross section of these silos of things doing common stuff. And this is why I think like Azure Data Factory, Amazon Glue, and things like that are kind of getting created because they're seeing so much overlap in the things that we do and have to automate on a consistent basis. The other thing is that I think as I've progressed, there's been, it feels like a split in the last couple of years, and I almost wonder if it's kind of coming back to the point where like UIs are still valuable if they're done easily. You know, one of the challenges that I've had is I did this one project where I created self-service tools to all of my internal stakeholders, and I did this via a CLI, and the people that could use the CLI and, you know, was able to set up the SDKs and the environments, like they liked it, they got to use the functions, but probably 80%, 90% of the people that I kind of built it for weren't really able to use it or integrate it into their flow because they didn't really want to mess with the code for all that stuff. And so, you know, building apps kind of with a UI component to them became valuable. And for me, I started building UIs that were really crappy. And so that didn't really work very well. Another reason for apps is kind of they're a little bit more targeted and focused. I've done several projects in the past where it was just this very large, sweeping platform, learned a lot from all those things. But for the business and trying to get business value, it felt like those big sweeping projects are not really what most businesses want, and they want like fairly narrow problems to solve their snowflake way of dealing with stuff. But, you know, kind of circling back to the silos and things across broader spectrums, there's probably lots more people trying to do those things if they can configure and tweak things, and this is where the UI kind of helps, letting business users and other people kind of self-serve for the things that they're trying to do. And then the last piece for us that became really critical was distribution. I think DevOps data engineering is becoming more of a productionized kind of process. Before, back in the early 2000s, late 90s, I used to code and write just scripts, and they would just get run on some laptop in some closet somewhere, and that was production. You know, nowadays we're going through build processes. We've got lots of automated tests. Not all teams in data or DevOps automate their tests the same, but I think it's becoming more important that things that people build are becoming productionizable. And part of the reason why I think that's becoming a thing is because it's so much easier to productionize code via the CI/CD tools, the Docker infrastructure, and things of that nature. Just out of curiosity, how many people here deploy their data pipelines through code?
Yeah, one project we have Ansible script that kind of packages up something and pushes it up to like a AWS cluster. So we
Gotcha.
use Ansible for that.
And then is that also have like a UI component to it, or is it more just like uh, deploying small, like narrowly scoped scripts like lambdas.
Yeah, narrowly scope, we own the process, the no UI, we run an Ansible, basically like a cron job that runs an Ansible script.
Gotcha. Awesome. So that's kind of like why we're like, apps, they're kind of a pretty good model. Phones for apps kind of like revolutionized phones and increased a lot of like the productivity and the reuse of certain functionality and things. And then another kind of side effect of this architecture that we didn't originally intend is, the ability to kind of share stuff not only within a company but also across companies a lot easier. And then, for me, kind of being semi-entrepreneurial, the ability to have like a side gig as part of this, where, I probably have built things that collect data from Google Analytics or Salesforce or other things that I've done for, some companies. It may have taken me weeks, months, days, whatever, but those things are becoming increasingly more valuable to broader audiences. And so for us, the definition of an app is something that can be run dependently on a platform, and it is semi-self-contained. You give it some parameters, and then it does what it's supposed to do, and then it shuts down. Or, I mean, it can be a service type app, but it doesn't have to have too much other stuff to kind of spin up and spin down. And I think people familiar with Docker are like, yeah, that's almost exactly what like a Docker container is. It's just the platform with which it gets its parameters, the platform with which it gets credentials and things like that needs to be fleshed out and pretty solid. And so the interesting thing for us is kind of like how far or how user configurable do we make these things so that we don't become bottlenecks for the work that we do. And so I've worked at a couple of shops where the data pipelines were just all in code, and the deployment was pretty monolithic. It was redeploy everything. We were using Airflow at the time, and the end users of the data could kind of look in Airflow to see what was going on, but they really couldn't change anything, configure anything. And like anytime someone made a request, it went through the Jira system, the ticket system that we had, and it would typically take a week or 2 weeks to get done if it was high priority. Some of these things obviously sat for a long time, and the challenge that I had here was, why is someone waiting for something that they know how to configure more than the data engineers know how to configure? And these may be things like enabling people to automate their own SQL statements for certain types of pipelines. We had like web scrapers or things doing backups, and we wanted to give people the ability to scrape certain search terms on their own. And this kind of kept going back and forth with, in my head, like, what do I enable users to do versus what does the DevOps/data engineering team own and control, and how do you make all that play nice together? Because obviously when you become too much of a bottleneck and not enough stuff gets done, the business looks for solutions elsewhere. The other thing about the apps is, kind of in line with the distribution and scaling, a function can be run millions of times, one time, and it just needs to be able to scale up. And so if you have something that the finance team runs and the marketing team runs and the BI teams are all running to like automate queries, they should just be able to spin up their own instances of those apps, and maybe run them on the same platform or multiple instances of the platform, but you control that in the same place. Self-contained, kind of went through that already. Easy to build. I think this is kind of a new one for us. We originally went through, as we were like ramping up on Docker and all this other stuff, on like how to build apps effectively and cleanly. And one of the things that I forgot is how old I was. I initially thought it would be really easy for people to build apps that in Python, just because Python itself is easy, but then I kind of forget that I've done Python development for a long time. I know a lot of the best practices. I know how to find stuff. I know how to dig into documentation and get libraries and all that other stuff. And we did some like scenarios where people were building custom apps internal to their company, and they were having a really rough time because the skill level of the developers, they just didn't have the years of experience, or it was kind of a new paradigm. And so that's something that I think if apps were easy to build and you potentially knew that you could have tens to hundreds to thousands of people using an app versus publishing some snippet on GitHub, would people expose their functionality in a way that other people could leverage without having to read through your code or set up, development environments? And that's kind of what we want to get to. So the platform that this is kind of dependent on is built on a whole bunch of stuff. I'm going to kind of go a little fast here, but all of these things are probably synonymous with services that if you've got like an enterprise semi-microservice kind of platform or system that you have somewhere inside your systems. And so React.js is our UI. We're using Redis for our queuing mechanism. Flask is our API. Trafic networking. MinIO is for a storage, I guess, what's the term?
It's like S3.
It basically turns all storage interactions into S3 actions. And so you basically say, I'm going to run this S3 command to copy to MinIO, and you pre-configure MinIO to be either an S3 bucket or a disk drive or a Google Drive or a Azure drive, and it doesn't matter underneath the hood. So instead of us like writing libraries for each of those different backends, we just use MinIO, and it can write to all of those things if we just give it the right config. Does that make sense?
Like it's basically just a config file that spins everything up, and then I guess I say it's like a Docker file kind of. It defines
Yeah.
what the scope is, and then it gets.
So like a storage abstraction interface layer for just cloud storage.
Abstraction. That's what I was saying. Yeah, and it could be cloud storage. It could be local storage. It's more just an abstraction layer for storage, kind of following an S3 paradigm, which is one of the things we were like pretty used to. And the notion is the platform, just like your phone OS, does a whole bunch of things to make or enable apps to run. And one of the things that we needed to kind of build a very consistent way of interaction was how to interact with storage. So we have Grafana for some visualizations, and then we kind of powered our backend database with MySQL. And anyone kind of familiar with Airflow, I think the platform that we're kind of working on and building is very similar to what Airflow has kind of designed. One of the core differences is that the way that you run things is via apps instead of DAG tasks. And users can configure and kind of have control over things that they want to own and maintain, and do that in a collaborative way with maybe projects or data pipes that data engineers can own and control, only through code. And so this is kind of one of the core issues that I saw was data is never only code only. It's never only business only, and there's just so many different things that people are trying to do. We couldn't build all of these different kinds of apps, but that's not to say that they're not valuable, and it's not to say that there's not tons of people kind of doing the same or similar things, maybe just with a slightly different configuration. And I think the number of apps that could be built for the data DevOps space is growing pretty significantly. And the only people kind of getting the benefits for those things today are these big companies. And even, I think open source is an amazing ideal, but it feels like the majority of open source today, when you take a step back and look at like what is the offering, a lot of open source companies are, have this big enterprise arm, and the open source process is, hey, contribute to our open source so that we can make more money. Obviously, they have a free component for their stuff, but I think that there's potentially another way that's kind of in between, where you can contribute and make a revenue stream for yourself via apps. And I think apps on your phone kind of was a model that was really appealing to us. So the platform, you saw all the like inner workings and components. The platform does a lot of things that like Airflow does. So it handles the UI. We have really granular levels of permissions on resources and objects, projects, folders. Orchestration is kind of a requirement. Deployment and testing for the apps is kind of another backend requirement, as well as like billing and subscription for apps that are public or third party, or that can be installed and downloaded across potentially the world. And so that's kind of what the app ecosystems are responsible for, no matter whether or not it's iTunes is, I think, another ecosystem similar to this. They just sell music instead of data tools. Obviously, apps on your phone is another big one. But I think if you were going to try to do this for data engineering, a lot of the orchestration, automation, security, like more enterprisey level features are the things that you want to build in a platform, so that developers don't have to worry about those kinds of time-consuming concerns, or maybe concerns that they don't care about when building functionality that is valuable to the business. There's been so many projects that I've worked on where I got the first MVP of some sort of functionality out, and everybody was like, oh, that's great, and then everybody thought like the projects were going to go super great, and then someone says, oh, and by the way, it needs to be SOX compliant, or oh, by the way, we need to add XYZ granular levels of permissions, and then we're like kind of grinds to a halt, because a lot of that is a different skill set, I think, from what a lot of backend engineers, unless you're a full stack, have a lot of experience in. And I'm frankly back end because I don't really do a good job at UI, and I'm not that interested in it. So oh yeah, and the logging, scaling, routing, version control, configurations, all that other stuff. All right, so I think this is where I generally do a little bit of detail diving into what the platform kind of looks like. And so can everyone see this?
Yes.
Yep.
Okay, awesome. So if you're familiar with Airflow, it may look really similar. It manages your connections, it manages orchestration, kind of scheduling. You can trigger things off of other triggers. You can kind of create tasks. And the core of like what the SDK kind of does for this is it takes something that a Python developer can build. So in this case, it's a hello world function. And then what we do is we say, hey, if someone wants to use my function, I need to describe the inputs that I need. I kind of need to do a better job of describing what I do, because it's tons of times when I write functions that I'm like, man, what the heck did this do? This kind of forces you to do that if you're trying to publish it. But you say, in this case, I need a name. So if I want to say hello banjo instead of hello world, I'll put banjo in here. And then I'm just saying hello world and logging it to the console or the logger. And so I'm just specifying how many times that I want to do that. And so what the platform does is it takes your Docker container that you've built, packages it up, and then creates this contract in terms of parameters and how you get your connections and things like that, so that someone on the other side doesn't have to know about your code and all your underlying stuff. They can just run it through the UI and configure it themselves. And so you define an action, you define an app. We call them engines because we're data engineers, but everybody else kind of thinks about these things as apps, which for better or for worse. And so what it turns into is this. And so this UI was kind of automatically generated. DC DataOps. Save and configure, run. It's going to pull the latest definition. It's going to pull the latest version of the container. It's going to run. And then, you kind of get the benefits of like execution management, version control, histories, things that, we kind of do on the back end. But if we're going to expose functionality to business users that they don't want to have to worry about, so we kind of have to build it for them underneath the hood. And so it can do things like light dashboarding. I mean, if you can do it in Python, you could build it as an app today. And then, potentially it could be part of this like collection or community of people building apps that are solving a lot of different types of data related business problems, or actually doesn't even have to be data. We've talked with people about building cost analysis collectors for BigQuery versus Amazon cloud costs. And, it can be DevOpsy type stuff. It's usually some sort of automation. And I think we started with data because I'm more of a data architect, but it's kind of evolving into something where it doesn't really matter what you do as an engineer. If it's something that you're automating, it's probably something else. It's probably something that someone else is automating and potentially would be valuable in something like this, whether it be free or paid. Any questions on that so far?
So we'll save questions for the end.
Okay, awesome, thanks. So one of the things that has come to mind is, Docker containers, and we're almost like a Docker execution platform. Docker containers are great, but they're pretty low level still. And, I can't go to like my data analyst and be like, here's a Docker container, go nuts and do your stuff. And so like the reason why we kind of built these apps and engines is to be more end user focused and make it easier for other people to run and leverage the things that you package up as Docker containers. And so it's about the UI, it's about the user experience and automating it into things that they have in their flows. And then on top of that, it's about everybody kind of enabling self-service a little bit more with what they do, which I found is a little bit harder than I initially thought, because from a more technical perspective, a lot of things that I built initially were still too complicated for some of the target users that I was targeting. But then there are certain things like we have a bunch of apps that basically you run a SQL statement and it'll send alerts to Slack or send emails with charts in it. And those are things that I feel like I've built, 10 or 20 different times for people at prior places, just because those are things that shouldn't be gated by data engineers. So where does it run? The platform is very similar to Airflow. It's designed to be installed on your own servers or systems. Obviously, there's cloud installations if people want it. But one of the goals of like data is that you have full control over where your data flows. And I feel like security and privacy concerns, it's becoming more paramount that architectures like this are kind of being developed. I think the startup industry has kind of gone SaaS everything, and I don't think that fits everybody. The other thing about this that is kind of interesting for us is that the ability to kind of have custom app code that you develop, whether it's private IP that the company owns, or whether it's just like private apps that you want to build for yourself. Like, you don't have to share your stuff, and if you don't, that's fine. The platform is, free for X number of users or less, and you can just build all your own stuff and automate, things via this and have like a really tiny team that gets, a lot of benefits around like UIs, additional SDKs, additional community development as well. And I think this also potentially changes a little bit about the way like companies have to do build versus buy. One of the things that I've seen is companies are like, well, we buy this like really expensive SaaS platform or enterprise software, or do we just go open source and hire a team to do things? And I think this kind of gives you a mix. You know, you can subscribe to something for $100 a month and it's not like a big decision. And if it doesn't exist, then you can just spend, you know, the week or two to build the app that you're looking for and kind of integrate it with your flow. Testing considerations, that was really big for us. I think by focusing on an app-like model, you make it easier for yourself to test certain things. One of the things that I've seen in lots of like DevOpsy or data, like large scale data architectures, is like people trying to build tests across like end-to-end pipelines and things that like I would say in many cases aren't even things that you can control that end up getting tested. And it kind of puts a bad taste for testing in like the DevOps or data engineering side of things. And so I've talked with, you know, several groups of people that are like, oh, for data, like we just don't do testing because it doesn't actually catch the types of things. But if you kind of like narrow the scope of what you're trying to do in a lot of cases, it makes a little bit more sense. And for us, especially if you're deploying apps to like multiple people, you have lots of stakeholders leveraging your apps. This is where, you know, having CI/CD pipelines is helpful. And actually, we actually have kind of like PyTest integrations kind of built into our templates for everything. And so in this case, this is the two tests that we're running. We're making sure that the arguments are being collected appropriately and that the replacements of the name are being appropriately substituted. And so these are pretty basic and small tests. And the way that we integrate it with our pipelines is via GitLab. We actually have people doing this on Jenkins as well. But the SDK has pretty robust like command line. You can deploy tasks. You can update tasks via command line. And so you can also deploy engines or apps via command line. And so in this case, the tests that get run is we run a linter. And then here, we actually have a repo that has close to 100 different apps in it. And what it does is it detects code changes for the specific apps that we run. And then, or code changes that happen for the apps that we modified. And it only runs those tests. And so usually you have some sort of shared libraries. If those get changed, it runs a different suite of tests for everything. But for the specific apps, if you're making changes to those, it knows to just go in and run this CSV Parquet formatter app that we built for somebody. And that way we can kind of increase the quality of changes and reduce the risk of kind of like weird stuff getting dumped into apps that people end up using on the other side. Couple of challenges with this architecture that we kind of built. Okay, so originally when we started with the platform, we started with only 2 Docker containers for everything. That became a bit of a challenge for us to like maintain and upgrade. One of the important things for us was having like a 0 downtime upgrade path. And so when you run the upgrade process, it'll actually spin up another container for the critical path of what it's trying to upgrade, and then it will shut down the old one. And so this becomes really important because I think when I was doing this with Airflow, if I had a really long-running job, I just had to kill that job. And so now with this architecture, more the Docker architecture, like those kind of tasks can continue to run because they're not part of what we're upgrading. We're only updating or upgrading certain components along the way. And so it made sense for us to split up the different services on the back end as we were kind of going along. The other thing is we used Vue.js as our first UI. That's mainly because I was more full stack, and Vue.js was easier for me to kind of like manage in Grok. And I think as we've grown and as we have like users on the platform, the UI is kind of becoming more important and more paramount. And so it was really difficult for us to manage because we weren't great at managing all the different components of a UI and keeping them consistent and testing them effectively. And so we got some React people that were really good at building cleaner UIs, managing them more effectively. We're still not where we want to be there, but Vue.js ended up being a lot more maintenance for us than we kind of wanted for the types of things we were trying to build. And the last thing that we ended up having issues with was Elasticsearch. It was a pretty big memory hog for us. We were using it for our logging initially. We swapped it out for Loki logging, and if the core of the platform was that it was be pretty self-contained. You can install it on your laptop if you want to, or have any of those underlying services in the earlier slides, kind of like as cloud services if you really need to scale up. And Elasticsearch we thought would be okay, and it's probably fine for some people as like a managed service via AWS or Google Cloud, but it just cratered the amount of memory, and so we ended up getting rid of it for something a lot leaner and thinner. So that's it. That's kind of how and why we built an app-centric kind of data infrastructure. And we're kind of using it to deploy tooling and manage tooling across multiple clients, and interested in just talking with other people about this idea.
So I guess is everything tied to the UI? I guess you set up the engine or the apps from the UI, and then I know people have their special use case. They want to export the data somewhere else. How would I guess I want to work in this environment to export it to my special use case?
So if you had a special use case around exporting data, so this is pretty common, whether it's connecting to an API or a database, you just have to provide the inputs in your UI. So I'll actually go through an example of some of our code here. I don't know if I'm allowed to do this, but so let's take BigQuery, Firebase. Is everybody kind of familiar with that?
Yeah, that's good.
Okay, so Firebase has, actually let's create task. Firebase has a few parameters that you need to kind of configure. And so what we do is we try to make the UI match what Google calls things so that people familiar with those services like know how to extract information and data out of those things. And so in this case, Firebase is like a big data kind of processing. A lot of gaming companies use it to store billions of like events in their systems. And so what we did was we kind of built this app for a few clients, and we said, hey, we're going to simplify the way that we deploy extractions from Firebase to our clients. And so we boiled it down to like, what do we really need? And so the first thing is we need a Google account. The next thing we need is our table in BigQuery for loading. So it can be whatever test table data set name, which is a BigQuery thing. It's really a schema. And then the project is like the name of the project that your credentials has access to. So DC data. And then you have another set of parameters that are like the Firebase components. And so essentially you might need different things. You would have some sort of like tracking field because Firebase is a document store. So this is kind of replacing what the document ID is. So document ID, and then the collection name, which is kind of like synonymous with tables in BigQuery. So this might be users, and then app is actually implied with the credentials for BigQuery, so it's not a requirement. But this is how an end user would just create the sink, right? They just specify the targets and the locations. And so if this was an S3 target, if you were extracting it to another database, maybe you're providing some additional like table names and things like that. But this turns something that like they would normally have had to go through a data engineer into something that they could do themselves with the information they have. And they actually probably already had credentials that are able to read and hit all this stuff. And so we kind of give them this, they test things out. And then at some point they say, hey, this is the sync that I want to productionize. I want to like, harden this thing. And so then we'll take it. And what they actually have is a JSON definition of what we have. So we'll take it, and sometimes they do it in a dev project or something like that. We'll take this, integrate it in source control, and then deploy to our like production project or production instance via this configuration. And it kind of creates an easier flow for less technical people, or even developers actually started doing this versus creating, like, I don't know how many people are in Kubernetes and Helm charts and stuff, but like creating all that crap from scratch has been the bane of my existence a little bit. And so now I go in and put it in the UI, and I spit out the JSON, and it actually is a little bit faster. And I kind of get the best of both worlds by being able to script. I can create 1,000 tasks in one deployment if I wanted to, or I can just kind of use the UI whenever I want. And one of the benefits is, I think with Amazon and CloudFormation, is like you can't stop someone from messing with your CloudFormation templates by going in, to Amazon. Like you can actually lock down projects from having like UI edit capabilities and only deploy through CI or command line credentials. And so, now I can be like, oh yeah, end user, go ahead, make stuff. Here's your gated area. You have access to these things. You can't see the credentials, but you can do your job faster, right? And this is one of the reasons why like a UI was so important to us, because I just kept going down the path of code only, and it definitely made certain things a lot faster. But then I left those companies, and then those companies were like, what the heck's going on? Like, we don't know. The turnover of critical people, like probably everybody in this talk, is a huge concern. And so now those companies are like, oh, if Nam leaves, like almost anybody can see the flow of the UI. They can kind of understand what's going on because it's packaged in easier ways that people can understand, if that makes sense.
Yeah, it's like democratizing the data engineering, basically.
A little bit. And, I get to work on more fun things, bigger backend services. Because I think for the data engineering side, there's always going to be some, Kafka instance or Kinesis stream management type stuff that we've got to like really dig into, because we've got to do worldwide deployments of these kinds of things. And those are things I'd rather work on than, syncing Salesforce data for the marketing team. Nothing against the marketing team or Salesforce. It's just not what I want to do. And so, if I could find an app that did that for me in a way like this, that I could point my marketing guy to be like, hey, you've got 600 tables in Salesforce that you guys are managing, and you're changing them daily. Like, you can break your own stuff, and I don't have to deal with it, right? Like, just here's the connections to the data lake or the database. Here's your, we have things like metadata configs. And so this is stuff like, if you have data in a data lake in S3, here's the definition of the column so that it can be loaded into Redshift or Snowflake or whatever. And so what the analysts do is they just say, hey, I want to load this table from this data lake into this database technology, and they don't care what the DDL is for all those kinds of things. And now they have this. Now you have this tracking to say this collection or this S3 data lake table is being loaded in these 20 different places.
Having wasted several weeks of my professional working life trying to get data out of Salesforce, I can see the value. My question is, I'd love to hear you elaborate a little bit more about sort of how this fits into the existing landscape of other sort of managed ETL, managed hosting tools, because I see a sort of lot of similarities and capabilities to tools like Stitch, Segment, Zapier,
Yep.
and I'd love to hear you elaborate a little bit more about sort of what this platform is really good at compared to all of those other things.
Yeah, I think one of the challenges that I've heard is that there's a lot of different things that exist out there. And I talked to one CTO and he's like, is this another data management platform tool that I'm going to have to manage? Because all those guys are slicing off these narrow areas that it's not worth it for them to tackle so many different things, or maybe it's just not in their warehouse. And so I see actually quite a few companies that have Stitch, Zapier, and Fivetran, and whatever homegrown system that they've got. And so the question is, like, how would you combat that? Like, it feels very desirable to have a place that unifies that in some way, shape, or form. And the only way to combat it, to me, is to have a community-driven platform. And I think open source for those kinds of things is a bit challenging, because once again, the story that Stitch and Fivetran say in many cases is build open source stuff for us so that we can sell it and make more money. And I think that developers that only consult for time, even though they have a lot of knowledge, might be interested in building a revenue stream for themselves. And so I think it's not that we would be doing any individual thing better, but that we would be bringing a lot of these things that companies have, multiple systems for, under a more unified interface. And you may still interact with them, but like managing the triggering of what's going on in those things through something like this and having the ability to integrate like your custom Snowflake stuff with the more mainstream other stuff feels like a benefit for us.
Yeah, well said.
So if you're using, like Airflow, you basically have the open source Airflow, and then you have a managed hosted version of it on Astronomer.io.
Mm-hmm.
I wonder if the platform piece of this has those two capabilities or offerings.
Yeah, so I would say we are capable of replacing probably a big portion of what Airflow does. The astronomer.io component would also potentially be replaceable because we are able to like run things on Swarm. And so I think it's really interesting, because what astronomer.io does actually isn't it's kind of like the things that are on the other side of the fence seem really hard and complicated. But if you were to say, oh, I just need something that can auto scale resources to do data tasks and data jobs, like I think that's what astronomer.io does, right?
Yep.
And so essentially something like this would be able to run your individual tasks on different resources like Fargate or ECS or Kubernetes, and that kind of potentially allows you to do that auto scaling resourcing in multiple ways, right? So I would say we're probably not there to be able to completely replace Astronomer yet. Like, we're probably not as easy to scale that up. But I think eventually what we want to get to is where you install this locally on your machine, you have a few ways that you can run your tasks. You can run it on resources managed by us, or you plug in some Amazon credentials that can manage spinning up EC2s whenever it needs, or you can run it, you could probably still run it on astronomer.io if you wanted to. But that kind of flow, I think, is becoming easier.
Yeah, I'm actually interested in, and like, for example, Spark has a managed version of it, which is, it could be Databricks, it could be Qubole. So I was wondering if if you have an open source version of the platform that could be inserted in any in any EC2s or what have you on-prem, And then is there a a platform that doesn't need any involvement from me, so that I basically just want to keep on subscribing to these different apps that are available from the community, and I don't want to touch the platform at all?
So could you elaborate on the second part of the question?
Yeah.
Yeah.
So in the same way that that Databricks is basically, it doesn't allow me to install Zookeeper or manage my clusters. All of those are being done behind the scenes.
Yeah.
I was wondering if there's a version of this where your platform would be hands off from me, because I really just want to leverage the existing apps that the community is creating. So if I want a BigQuery component, for example, I would just subscribe to that while using your platform.
I think that's where we want to go. I think there's, in my head, I know too much, and there might be, upon initial configuration, especially if you're installing it locally, like telling it where to run some of those pieces. But we eventually want to get to the point where people can just subscribe to the app and just use that, and then not have to worry about where things are running on the back end.
Gotcha.
Like a SaaS, like you're thinking of like a SaaS, like API endpoint that's passing the parameters and just all this in the back end without having you to go through the interface, basically.
Pretty much, so that like I don't have to maintain or update any servers that this would be using.
Right.
Oh.
Yeah.
Okay. That makes a little more sense. So it wouldn't necessarily be something that you wanted to install on-prem, but you just want a hosted version where we're maintaining the execution and management of all the resources on the back
Pretty
end.
much, yeah.
Okay. Yeah, that's actually probably end of this year for us.
Gotcha.
Yeah, well, thank you, now.
Yeah, I had a question about the you made the analogy a few times to the apps on a phone, and it looked like you had a little app store going. Or there are third-party apps in there that you then get?
So yeah.
And if they're not open source, do you run into any of the same issues that people have run into with phone apps, like privacy questions or malware or anything like that?
So right now, since we're still pretty early, we're heavily reviewing the code that gets in to make sure that there's no malicious stuff. There aren't any privacy concerns yet, because we're not having any apps take your data. Well, so the only way an app has access to your data is you give it the credentials to access that. So it's kind of like circumventing that licensing agreement for that. But does that answer your question?
I'm not sure I quite get that, because I mean the app is some program that's running, and it's doing something with your data.
Yep.
And I mean, I guess the problem with phone apps is a lot of them are just sort of evolutions of websites where there's a third-party service being provided, and they need some of your information to do that. I don't know if you have apps like that, or would intend to have apps like that. So,
yeah,
I mean, I don't know if you just prohibit the app developer from using their own backend or from retrieving any data from the user for now?
Yeah, we don't have the notion, like, I guess the reason why the apps on their phone have to do that is because all apps on your phone share common things like contacts and user information or financial information that's stored on your phone. And so these apps are actually more narrowly scoped to where you're actually, as part of the design, only giving them access to like this one database. And whatever credentials you give it to do that are scoped to whatever those credentials have capabilities to. So I do kind of envision, like, as this thing evolves, there's going to be more UI type apps, but I still think they will be fairly narrowly focused, and whoever administers like the credentials for those things will have full control over what the apps have access to.
Right, but of course, I mean, at least with looking on phones, you have sort of some granularity over what the app can see. But as long as you allow the app to connect to the internet, you can't, anything that it can see, it can also phone home with, right?
So yeah, that's,
you can't
And so now I guess you're talking about like this trust issue. You want to make sure that like this BigQuery runner isn't just taking all the BigQuery data and then sending it off to China, essentially. And so,
or even just to Google or Amazon or whoever might, or maybe we're not worried about them, but some other
right.
third party but because for some of the things that phones do, they need the service is actually being provided by their backend and they need the information, right?
Yeah. So I would say a good use case for something like that is we're working with a web scraping developer that scrapes like Amazon. And so he was kind of thinking about it in terms of like, if he had an app that was making all these duplicative requests to Amazon, that would be, that app would most likely get banned in lots of different ways. And so from his perspective, he was thinking that it would first make a request to a central API system on his side. We're kind of tracking what he sends. In this case, it's search terms. But if it's it would basically say, hey, have I, requested data for this product from Amazon before? If so, here's the cached results instead of actually going and making the call again. And so we're heavily integrated with these architectures. And I think, similar to Play Protect or, whatever kind of verification systems are, it's up to us at the moment to make sure that nobody's doing anything malicious of that kind of sort, or if they're doing things like that, that they're not doing malicious things. And that may not be a good answer to your question, but it's definitely a concern that we're trying to tackle like long term. Like how do you and Google, or how do we and Google maintain the security and integrity of everything that flows through the system and platform, and how quickly can we ban those things? I think the challenge there, the most egregious thing that would happen is like we've worked with someone that's done a ton of good work for us, and somehow they deploy some sort of malicious thing suddenly. Would we be able to find it within a day or two, and would people be impacted?
And there I have a follow-up question, though you may have mentioned this already. Are the third-party applications, if you're running the platform on your own cloud, are they run locally or?
Yeah, they are run locally.
Okay, so that helps somewhat.
It helps somewhat, yeah.
And on that question, how hard is it to develop an application and get it on the store?
So this is an example of like a full-fledged app that says hello world. I don't know if it's on the store or not, but essentially the hardest part that we've found with developers is describing, like naming is hard, documentation is hard, describing what they're actually doing and trying to make that a little bit easier is the hardest part. Usually most people that we're working with have done things that they know what they're doing, so they already know like functions, or they have functions in their back pockets of things that, sync data from Salesforce, for example. But trying to make it a little more user-friendly is where it takes probably more time. We've had, some of our first developers built apps, and the first apps, take a week or two. But we had one developer that, he's now building apps in like a day or less and then submitting them for review. So.
Very cool. And as an app developer here, or rather, do app developers get any kind of telemetry on how their apps are being used, apart from how many they sell?
I think we're trying to keep that thin, once again, for like privacy concerns. So right now we have subscription and I think like error statistics for the apps. It may be something where we need like to add more for that, but for sure.
Very cool.
Sorry. Actually, I got kids screaming at me. I got to get going.
No,
sorry, guys.
That's
Thanks
awesome.
a ton.
Thank you.
Yeah.